one point I heard that they could actually change the line from their own computers to type.
Yeah, they can. Well, we don't give everybody permission to do that, but yes, they can. Here's how it works. One of the things we do is we actually, when we want to build an engineering prototype, see, what happens in one of the key things that manufacturing can contribute to competitive advantage is time to market. Why is that? Because the way most things work is you design your product here, and after you're done, you throw it over the wall and you design your manufacturing process here, right? Sorting out a bunch of things that maybe weren't done right here, fixing them, changing them, and then completing the process design. What you want to do is do this and ship it right here while your competitors are still here. And that's what we've been able to do in many cases. What we do is we suck data out of our CAD systems in engineering. We zing them around over the local networks over a T1 to Fremont. The factory's about 15 minutes away. And in our own computers, we compute all of the robot placement programs, fully optimized path. We compute all the vision system programs. We check it against the bill of materials in the IS system. And we download it to the robots, and we're ready to build a board, lot size of 1, in between 2 production CPU boards on the line. Full surface mount with all of our automation technology. Now, the key is that manufacturing did that so well for engineering that we haven't built a prototype in engineering for 2 years. We haven't built a wire wrap or any other kind of prototype in engineering for 2 years. Everything has been built in the factory. Now, what does that mean? What that means is manufacturing gets involved from day one, right? Because the engineering guys call up manufacturing and go, hey, we want to build a prototype. We're going to need these special parts on the thing. Take a look at this. Tell us what you think. We'd like to do it tomorrow. Let us know if that's OK, blah, blah, blah. They get involved from day one. And what it also means is, so we get this parallelism. Secondly, a lot of times when you build prototypes, it's not quite the same technology as you're going to use in production. And so all the accumulated knowledge you get from building your prototypes, you throw away when you change technology to go into production. And you start over in that accumulation process. Because we don't change technology, we don't throw anything away, we don't waste time. And it's led to one of the healthiest relationships between an engineering and manufacturing group I've ever seen in my life. They're all working off the same databases. They're all working on the same processes. They're all working in a very disciplined process environment to where when any processes are changed, they all get together and review the proposals and all buy into it. And it's not that hard. The key to it all, though, was we didn't go out and hire a bunch of manufacturing people. We went out and hired engineers, and we convinced them that we were going to be different. We were going to pay them exactly the same. As a matter of fact, we paid them a little more at the beginning. But we pay them exactly the same as R&D. No different. There's migration both directions. Not just from manufacturing into R&D, but both directions. And they're not second-class citizens. They have the same offices. They have the same test equipment. They have the same computers on their desks. And it took us a while to convince them that we were really serious. For about the first few years, we had more PhDs in manufacturing than we did design engineering, until design engineering stole a few of them away. So it's really paid off for us, and I think it's one of our real opportunities for competitive advantage.